So in this video, we're going to talk about permutations with non-ordered elements. We're going to look at some examples of permutations with like elements and how to handle those, permutations with several identical elements, and distinct objects in a fixed order. For example, one, we're going to deal with permutations with like objects. So in a three-letter word like top, you have distinct letters, so each is different. And so we have three choices for the first letter, two choices for the second letter because we've used one in the first slot, and one default choice at the last slot. So we have six choices, 3 times 2 times 1, you have six choices for this. So it's interesting in the word to, where you have double O's. So I'm just going to call the first O01 and the second O02. And I'm just going to list out all these permutations where order counts. So we're going to treat O1 and O2 as different things. But in reality, these and these and these are all the same. So really the number of permutations we have is actually 3 instead of 6. So this brings us to our rule when we're dealing with permutations with like objects. The number of permutations of n objects when p of one type are identical, q of another type are identical, and r of another type are identical, and so on, is number of arrangements would be n factorial over p factorial times q factorial times r factorial, and so on. Okay, so a hockey team ended its season with 12 wins, 8 losses, and 4 ties. And how many orders could these outcomes have happened? So in total, we want to add up how many games we have. So 12 plus 8 plus 4, we have a total of 24 games. And the number of ways that we can arrange all these possible types of like wins, losses, and ties would be 24 factorial over, and now we're going to take all the wins, so that's 12 factorial, and all the losses, that's 8 factorial, and all the ties, which is 4 factorial. And that gives us 1,338,557,220 ways. So just to summarize, the number of wins and losses and ties can be seen as repetitions. And also, when you're putting this in your calculator, make sure you bracket the denominator. Otherwise, you may be multiplying or dividing by 12 factorial and then multiplying your entire answer by 8 factorial, 4 factorial. So if you're not getting the same answer, chances are you need to bracket the denominator. Okay, for example 3, how many ways can the letters of the word minimum be arranged? Now notice in the word minimum, there are 7 letters, but we have some repetitions. So you have 3 M's and we have 2 I's. And so this is kind of similar to the 1B example that we did with 2, the double O's. So here we're going to use our formula that we just came up with. So 7 letters, that means 7 factorial. That would be with the repetitions, so with the doubling up with the M's and the I's. So we need to divide out the repetitions. So we're going to divide out 3 factorial times 2 factorial. And we can actually simplify this instead of using our calculators. We know that 7 factorial is 7 times 6 times 5 times 4 times 3 factorial. Let's stop there because we want to cancel out a 3 factorial. Divided by 3 factorial, these will cancel. And then we have 2 factorial, is 2. And this can reduce with the 4. So now this is an easy calculation, and this is 420 ways. Okay, for example 4, how many ways can the letters of the word sensibility be arranged so that the word begins with an E? So in sensibility, we have 11 letters. Now, the first slot has to be an E. So there's only one way to put an E in that slot. So that is it. And then our second position will have a choice. We have a choice of 10 letters. And then once we've used one of the letters, it becomes 9 letters. And so you can see this becomes 10 factorial. So now let's look through the word sensibility and see if there's any repetitions. Noticing that there's 2 S's and 3 I's. So of course we need to divide those reps out. So we have 10 factorial, right, times 1, the E, which is still just 10 factorial, over 2 factorial times 3 factorial. And we can simplify here a little bit just to make our calculation a little bit easier. And we are left with 302,400 ways. Okay, so last example. How many ways are there to arrange the letters in the word number if the consonants must remain in the original order? So you can place the consonants in any position, but you must keep them in the order NMBR. So some arrangements, like some possible arrangements, can be NMBEUR. So notice NMBR are still kind of in the same order. Or UNEMBR, or NUMEBR, or NEMUBR. And all of these, you can see that NMBR are in that order. It's just you can populate the rest of the positions with the vowels. So since you cannot arrange the consonants in different order, you can treat them like elements. So using maybe, let's say, C for each consonant. So rewrite the letters as wherever you see NMBR, we're just going to put in C's. This makes it easier to imagine. So our N, we have 6 letters, right? So that's going to be our N factorial is going to be 6 letters. But now we have to divide out the repetitions, and the repetitions are going to be 4 because we have 4 letters that can't be, they have to remain in that position. So if you want to think of them as like elements, that's easier to see. It's going to be 6 factorial divided by 4 factorial, and that gives us 30. So there are 30 ways to arrange the letters, keeping the consonants in the original order. That's all for now. Thanks for watching.